Character. 5 semicircular conducting plates, each with radius A, are attached to a conducting rod along their common axis such that the plates are parallel with a separation gap G between adjacent plates. A similar arrangement involving 5 additional semicircular conducting plates, another one of this with this common rod, so these have this common rod, is attached to a second conducting rod, so this is important, second, symmetrically intertwined upside down with the first arrangement such that the plates can rotate freely as shown in figure. The two 5-plate constructions with an adjacent plate separation of G over 2, so this separation was G, now it is G over 2, are insulated from each other and wire leads are attached to the separate axles. Okay, so separate axles, therefore we have the same voltage appearing on these and same voltage appearing on these, but these two do not have the same voltage. This is a common type of variable capacitor with a capacitance proportional to the overlap angle theta. So these two plates overlap for a certain angular separation here. So we have this angle theta, that is the overlap angle. So this angle is theta. All right. Part A, determine a formula for the capacitance C in terms of A, G, and theta, where theta is in radians. Okay, so if I look at this setup here, I have the overlap angle theta, and the overlap area between these two conducting plates will be determined by this angle. So how much is that overlap area? Well, the area of the full disk is pi a squared. That's the radius, where a is the radius. So the overlap area will be pi a squared, but we are only considering an overlap angle theta here. So theta divided by 2 pi. So you can see the full area of this circle is pi a squared, but for this portion of it, we have theta divided by 2 pi. That's the fraction of the area that is going to overlap with the other plate. So that's pi a squared times theta over 2 pi. So you can see that I will have these pi's canceling, and the overlap area becomes theta a squared over 2. What is the capacitance between these two plates? The capacitance C is, because it's filled with air, epsilon 0, permittivity of free space, multiplied by the overlap area A divided by the distance between the two successive plates. So it is epsilon 0 multiplied by the overlap area, that is theta a squared over 2, divided by the distance between the plates, which is G over 2, between the two oppositely charged plates. So you can see that these 1 over 2's will cancel, and I will be left with a capacitance of epsilon 0 a squared, epsilon 0 a squared theta divided by G. But that's just for two plates. So that's basically considering these two plates, one capacitor. In reality, I have 5 of them, 5 of the plates connected to the same source, same terminal here, 5 of the other plates connected to a different terminal. So they each have a capacitance C0. So you can see that these capacitors are connected in parallel, and parallel connection of the capacitors will give me an effective capacitance that's 5 times the capacitance. So 5 capacitors connected in parallel will give me an equivalent capacitance that is 5 times the individual capacitances C0. So I will find that the equivalent capacitance is 5 epsilon 0 a square theta divided by G. So that's the answer to part A of the problem. The capacitance of the setup is 5 epsilon 0 a square theta over G. Let's move on to part B. The plate radius is 6 centimeters, A is 6 centimeters, while the gap distance is 2 millimeters. This variable capacitor is placed in series with an inductor, inductance 100 microhenries, and a resistor 10 ohms. A voltage source is supplied by an amplified signal from an antenna, and the output voltage is taken across the capacitor. The circuit is used as a radio receiver that receives a signal frequency equal to the resonance frequency of the LRC circuit. To receive an AM radio signal of frequency 1180 kHz, what angle theta in degrees should be selected? Okay, now for part B, we have the radius given. A is equal to 6 centimeters, which is 6 times 10 to minus 2 meters. The gap distance G is 2 millimeters, which is 2 times 10 to minus 3 meters. The inductance is 100 microhenry. The resistance is 10 ohms. The resonance frequency that I'm trying to get, the resonance frequency is 1180 kilohertz. This is an RLC circuit resonance frequency. Okay, so I can calculate the capacitance C as 5 epsilon 0 a square theta divided by G, and when the circuit is at resonance, the resonance frequency omega will be determined by the condition XL is equal to XC, which means omega is 1 over square root LC, and omega is 2 pi times the resonance frequency. So this is 1 over 4 pi square FR square, which is angular resonance frequency square times L. So this is telling me that omega square is 1 over LC, or omega is 1 over square root LC. That's equivalent to saying XL is equal to XC, omega L is equal to 1 over omega C at resonance. Okay, so this is going to give me the value of the angle theta. Theta can be calculated as G, gap distance, divided by 20 pi squared epsilon 0 resonance frequency squared A squared L. So that's basically the answer for theta. So I can now substitute the numbers here. Let's see what this angle is. Theta is equal to the gap distance 2 times 10 to minus 3 meters, 20 pi squared epsilon 0 8.85 10 to minus 12. Resonance frequency 1180 kilohertz, 1.18 10 to 6 hertz squared. And then I have a squared, 6 times 10 to minus 2 meters squared. And then I have the inductance 100 microhenries, 100 10 to minus 6. So I want this angle to come out in degrees. So let's see, theta comes out in radians, 2.28 radians. So in order to convert to degrees here, this is equal to, I have to divide it by pi radians, 2.28 divided by pi, and multiplied by 180. So that gives me an angle in degrees, 130.6 degrees. So that's the overlap angle I need in order to get the proper capacitance to have this resonance frequency. Okay, so in this problem, I have 5 plates of a capacitor connected to the same terminal and 5 other plates connected to a different terminal. And there is a gap of G between 2 identical plates, G over 2 between alternating plates. The overlap area between these plates is determined by the area, full area of the disk, pi a squared, multiplied by the overlap angle divided by 2 pi, theta over 2 pi. When theta is equal to 2 pi, we have the full area, pi a squared. The capacitance of an individual capacitor here is permittivity of free space overlap area divided by the distance between the plates, which is epsilon 0 theta a squared over 2. The overlap area, the distance between 2 consecutive plates is G over 2. So I get epsilon 0 a squared theta over G. And these capacitors are connected in parallel because the bottom plates and the bottom plates share the same voltage, the top plates share the same voltage. So 5 capacitors connected in parallel, 5 times C0 is the equivalent capacitance. Now I want this to be part of an RLC circuit where the resonance frequency of the circuit is determined by the AM signal, which is 1180 kilohertz. In order to have this resonance frequency, this RLC circuit to be at resonance, omega square should be equal to 1 over LC. So XL is equal to XC at resonance, which means that the capacitance should be equal to 1 over omega square L. Omega square is 4 pi square FR square, and there's this L here. So theta is G times 20 pi square epsilon 0 A square FR square times L. So substituting the numbers, we find 2.28 radians, or converting to degrees, divided by pi and multiplied by 180, 130.6 degrees.